So if we look at some application questions with linear functions and with exponential functions, it's kind of a good comparison to make. So in a linear function, essentially you're always adding by the same thing. In an exponential function, you're always multiplying by the same thing. So that's kind of a good way to highlight the main difference between them. So in number 6, it says the cost of a certain item was $7 in 2020. Its price is projected to increase by $3 each year. Find the projected cost in 2022. So you would take 7 and you would add 3 twice. Or another way of writing that would be 7 plus 3 times 2. And that would get you $13. Then it says, find the projected cost in 2024. Well, 2024 is 4 years after the starting point in 2020. So I could just take 7 plus 3 times 4, and that would get me 19. So then for part C, it says, create a linear model that predicts the cost t years after 2020. So instead of just 2 years or 4 years, a generic model would be f of t is equal to 7 plus 3 times t. So then I could just plug in the years here for t, like I plugged in the 2 and the 4. And this would get me any year that I would really want. So for part D, it says use the model to find the cost in 2030. You would just plug in 10. So 7 plus 3 times 10, and that'll get you $37. So that is a linear function. Now let's kind of compare it to a similar question, but that is an exponential function. So 7, the cost of a collectible item, was also $7 in 2020. Due to scarcity, its price is projected to triple each year. So find the projected cost in 2022. You would take 7 times 3 to triple it, and then times 3 again to triple it again. Or another way of writing this is 7 times 3 squared, which will get you $63. So find the projected cost in 2024. That would be 7 times 3, not to the 2, but to the 4, because it's 4 years after. And that would be $567. So create an exponential model that predicts the cost t years after 2020. That would be f of t is equal to 7 times 3 raised to the t. So whatever the year is, I can just plug it in for t here, like we did with the 2 years and the 4 years. And then for part D, it says use the model to find the cost in 2030. So if you just plug in 10, then 7 times 3 raised to the 10, that's going to be a big number. Let's do that. 7 times 3 raised to the 10, and we get $413,343. So does this seem realistic long term? I would say probably not. It's getting way too expensive. So this model probably only works for the first couple of years. And that's kind of something in a lot of mathematical models. They don't always work for all periods of time. Sometimes you need to put restrictions on, like only use this model for the first 5 years, or this model is only accurate for 1 year. So that's something that we, in general, not just with exponential functions, but with any mathematical model, a lot of times you will see time constraints on them. But this is question 6 and question 7. This is kind of a good way to compare exponential functions and linear functions.